Everyone, welcome. Today, we're going to break down a really cool project about CAN communication between two TIVA microcontrollers.
Ever wonder how all the parts in your car talk to each other so reliably? Well, the answer is a pretty clever protocol. Here's Bao to get us started.
That protocol is CAN, or Controller Area Network. It's the standard in the auto industry because it's just so good at ignoring electrical noise.
So our project's goal? Send temperature data from one TIVA board to another using CAN. Simple enough, right? Now here's David with the hardware details.
Okay, so the TIVA boards are smart, they have CAN controllers built in, but they kind of need a translator to talk on the bus.
And this is our translator, the MCP2551 transceiver. It turns the TIVA signals into proper CAN signals.
Here's the whole setup. Each TIVA board is hooked up to a transceiver, with resistors at the ends to keep the signals nice and clean.
So with the hardware all connected, it's time for the software to bring it all to life. Over to you, Brad.
Thanks, David. This flowchart pretty much shows the whole software side of things. Let's look at the transmitter first.
It's a simple process. The first board reads its own temperature, packs it into a CAN message, and just sends it out.
The second board's job is just to listen for that specific message, pull out the temperature data, and then show the value. But, no project goes perfectly smoothly. Emmanuel's going to walk us through the hurdles and how we wrapped it all up.
Yeah, we definitely hit a few snags. Making sure the bitrate was identical was huge. Oh, and we had to track down a missing resistor.
But, solving those problems is the best part. In the end, we got reliable data transmission, proving the design worked.
And this really sets the stage for some cool future stuff, like adding more sensors or even an LCD display.
It really makes you think, right? With a solid network like this as a base, what couldn't you build?